Alright, let's dive in. This is section 1.7, radical notation, and we're going to split this up over 2 days. So this is day 1, techniques and rules. And as always, I just want to encourage you that when questions come up, and of course they're going to, I want you to write them there, just so you can bring them to class. And maybe you want to try Googling your question first, text a friend, email me, but if that's not an option, or you just don't want to do that, you'd rather ask me in person or ask your group mates in class, then just write it down right there. Also, I'm going to drop some personal information for an audio check just to make sure you're listening. So here we go. This is radical notation, day 1. So there's some perfect squares I want you to make sure you have memorized. Here, 1, 4, 9, 16. These are all perfect squares. What's 4 times 4? What's 7 times 7? What's 10 times 10? 12 times 12? Make sure you have those memorized. Along with that, we've been using these already, but along with that, I want to make sure that you also have memorized some perfect cubes. And you don't need to have all of these memorized, but there's only a few of them that come up in the book. So you can see 1 times itself 3 times is 1. 2 times itself 3 times is 8. 3 times itself 3 times is 27. 4 times itself 4 times 4 times 4. 5 times 5 times 5. 6 times 6 times 6. 7 times 7 times 7. Rarely your book uses this. It's mostly the first couple, up to 125. Sometimes 216. Alright, so just so I point those out, that's good. We are going to start by just a little quick review of what a square root is. What times itself is 9? That's 3. So the square root of 9 is 3. What times itself is 144? That's 12. And we bring down the negative symbol. Because the negative symbol is outside of the square root, you apply that later, after you take the square root. Negative 36. What times itself is negative 36? Well, actually, no number times itself is negative 36. You try to say that it's negative 6, that's wrong, because negative 6 times itself is positive 36. And positive 6 times itself is also positive 36. So neither of those two numbers work. No number that we know of so far, and actually a number does exist, and we'll introduce it later, but no number that we know right now, when you multiply it by itself, gives you negative 36. So you can say that there is no real number, no real solution. And that would be your response. However, if you take negative 4 and you square it first, then you get positive 16. What times itself is positive 16? That's 4. Notice that when you go from here, it starts as negative, and the answer is positive. That's kind of like if you had said negative 4, the absolute value of negative 4 is 4. The same starting number and same ending number. By the way, the answer is 4. You have to ask yourself, what number times itself is 8? When you multiply itself 3 times, so that would be 2. 2 times 2 times 2 is 8. So therefore the cube root of 8 is 2. That's what this 3 means. That means you're asking what number times itself 3 times is 8. What number times itself 3 times is 125? That's 5. Because 5 times 5 times 5 is 125. 3 times. What number times itself 3 times is negative 64? Well, you might be tempted to say that because of what we said here, there's no real solution. And there is no real solution to this one, but there actually is a real solution to this one. Check this out. If you do negative 4 times negative 4 times negative 4, that does actually equal 64, and the answer is going to be negative 64. So negative 4 times itself 3 times is going to be negative 64. So this, because it's 3, because it's odd, this number is odd, then you're allowed to have negatives inside the radical. But because here it's even, you could technically, there's an unwritten 2 right here. Because it's even, because this, wrong one. because this is even. The unwritten 2 is here. Because that's even, there's no real solution. What number times itself 4 times is 81? 3 times 3 times 3 times 3 is 81. So the answer is 3. 4 times, people. Wow, you could put really any number you want in there. What number times itself 4 times is negative 16? Well, I know that 2 times 2 times 2 times 2 is 16. But if I'm going to try and get negative 16, negative 2 times negative 2 times negative 2 times negative 2, that's still going to be positive 16. Because this is even, I can't, because 4 is even, all the negatives are going to cancel out, and you're still going to get positive 16. So therefore there's no real solution. All the numbers that you know are the real numbers, and there's other numbers that are not real, that are not on the real number line. We'll introduce those later. Okay, determine whether the numbers are meaningful replacements in the given expression. So if you were to try to say what's the square root of negative 2 or the square root of negative 16, they're not meaningful replacements because of the negative symbol. Again, no number times itself is going to be a negative 16 or a negative 2. So we just have to check to see if these numbers are going to produce negatives. So square root of 5 minus 2, that's going to be the square root of 3. And yes, it is meaningful, because 3 is positive. However, 1 minus 2 is going to be negative 1. No, not meaningful. Let's see, square root of negative 7 plus 3, that's going to be square root of negative 4. And no real number times itself is going to be negative 4. So is it meaningful? No, not meaningful. However, if you take square root of negative 3 plus 3, you get the square root of 0, which is actually 0. 0 times itself is 0, so yes, that's fine. It's only when the number is negative that it becomes not meaningful. Let's see, we've got 18 squared times itself is square root of 324, which is 18. So yes, 18 is meaningful replacement. Let's take a look at this negative number. When you take the square root of negative 1/2 squared, then negative 1/2 times itself is going to be positive 1/4. And you take the square root of 1/4, you get back to positive 1/2. You start out negative, and then it becomes positive. Well, that is a meaningful replacement. It's kind of like we took the absolute value of negative 1/2 and we made it positive. Squaring a number and then taking the square root is the same thing as taking its absolute value. Let's divide a line here. Square root of negative 23 squared plus 1. Yeah, that's going to be square root of positive 529 plus 1, which is 530. Square root of 530, which is a number. So yes, it's going to be meaningful. I want you to do this one. Pause the video right now, take your notes out, continue your notes, and tell me what the answer is. Great. So, I don't know if you notice a pattern, but whenever we have a number like, or an example like a negative number like this, -5 squared, if you start out, the number inside starts out as -5, and it ends up, if you do the simplification, -5 squared is 25, and the square root of 25 is going to be 5. So you start with -5 and you go to +5. It's very much like taking the absolute value. So in general, what we can say is that the square root of x squared simplifies down to the absolute value of x. So similarly, we can say that this simplifies down to the absolute value of x plus 2. Oops. Absolute value of x plus 2. Here, we can even break these two apart, and we can say this is the square root of x squared times the square root of y minus 2 squared. And then we get the absolute value of x times the absolute value of y minus 2. In fact, this pattern holds for all square roots where the radicand is even. If this thing is even, if n is even, then that'll work. You'll have the absolute value. If n is odd, then actually no absolute value is required at all. Very much like when we had -64, you simplified it down and you still preserve the negative symbol. So here, 4 is even. So therefore, we know we can take this to be the absolute value of x plus 2. The two 4's cancel each other out. Here, it doesn't look like a perfect square to begin with, but if you note that a is equal to x and b is equal to 4, then 2ab would be 2 times x times 4, which is what we have. That's 8x. Yay! So we can say that this is going to be a plus b squared, or x plus 4 squared. And then we can take the simplify that to be the x plus 4, absolute value of x plus 4. 9. All right. Well, the 3's are odd, so they will cancel each other out, and we'll just have -4xy, and that's the answer, because it's odd. 3 is odd. All right, multiply. So one thing that you may or may not remember from previous classes is that the square root of a times the square root of b is equal to the square root of a times b. So we get the square root of 19 times 7, which is the square root of 133. Here, we can multiply these two together. We get the square root of x plus 2y times x minus 2y. And when you FOIL those, or recognize that they're the product of conjugates, then we get x squared minus 4y squared. Sum and difference rule. And that's the answer. Here, since the 4 is the same, we can say that this is going to be 27 times 3, which is 81 to the 4th. Now, what number times itself 4 times is going to be 81? That will be 3. 3 times 3 times 3 times 3 is 81. Next page. Simplify 300. So here's a technique that you might notice, is that we're going to factor out perfect squares and cubes. So 300, there's a perfect square factor of 300. The perfect square factor, a number that is both a factor and a perfect square. So 300 has lots of factors. 300 has lots of factor pairs. But the largest perfect square that I can find is going to be 100. So I'm going to rewrite this with 100 first, 100 and square root of 3. I picked a perfect square factor. 100 is both a perfect square and a factor of 300. So that when I simplify this, I get 10 square roots of 3. That's simplified. Let's keep going. This is going to be 6y. And in fact, the absolute value of 6y, because of what we learned before. And actually, if you wanted to, you can split this up into the absolute value of 6 times the absolute value of y. And the absolute value of 6 is just 6. 6 times the absolute value of y. Here, I'm noticing that the greatest common factor is 2. So I'm going to take the square root of 2 times x squared plus 2x plus 1. I'm going to notice that this trinomial is a quadratic trinomial, and we've got a perfect square in the front, first term, that's x, perfect square in the last term, that's 1, and I wonder if this is a 2ab term. This would be, 2ab would be 2 times a times b, which is 1, so 2x. Yeah, this is 2ab. Okay, so great. That means that this is going to be 2 times x plus 1 squared. So that means I can split it up into two different radicals. Square root of x plus 1 squared times the square root of 2. And then I'm going to take the absolute value of x plus 1 times the square root of 2. And that's the answer. What number times itself is 16? Well, no easy number times itself 3 times is 16. It would be a lot easier if it was just the regular square root of 16, or even the fourth root of 16. So can I get a perfect cube factor? That means a number that is both a factor and a perfect cube of 16. Yeah, that's going to be 8. 8 is a perfect cube, and it's a factor of 16, because 8 times 2 is 16. So let's take the cube root of 8 times 2. Well, that's going to be the cube root of 8 times the cube root of 2. What number times itself 3 times is 8? 2 times the cube root of 2. That is simplified. And here, I don't exactly have a perfect cube, but I do have 4 of these terms. So what I can choose to do is find a perfect cube factor here. Perfect cube factor would be a plus b to the third power times a plus b to the first power. We've got 3 of the a plus b's over here, and then the last one over here. So I'm going to split this up into the cube root of a plus b cubed times the cube root of a plus b. Well, the 3's cancel out, and we get a plus b times the cube root of a plus b. Alright, so the same, very similar rule applies to division, in that you can split up square roots. So the square root of a fraction is going to be the square root of the numerator divided by the square root of the denominator. What number times itself is 49? That's 7. What number times itself is 64? That's 8. You get our answer. Number 19, square root of 25, square root of y squared. That's going to be 5 over the absolute value of y. Number 20, what number times itself 4 times is 16? That's going to be 2. What number times itself 4 times is going to be 81? That's going to be 3. The answer is 2/3. Split them up. 7, split them up. 125. Well, you can simplify the bottom. 5 times 5 times 5 is 125. But you really can't do anything with the top, so we just leave it the way it is. Cube root of 7 over 5. Next, can we find any of 75? Any perfect square factors of 75 would have to be either 1 or 75, 3 or 25, or 5 and 15. Hey, check it out. We've got 25 here. It's a perfect square factor. So I can rewrite the square root of 75 as the square root of 25 times the square root of 3. And I always write the perfect square first. It makes things easier because when I cancel them, these are here and this is 5. So 5 is the answer. Next, I'm going to use the fact that this is a fraction and I'm going to recombine them into one radical. So we've got 2x cubed over 50x. And I've noticed that I can cancel these, which is why I recombined them in the first place. This is 25 and this is going to be 2. So that means I have the resulting fraction is going to be inside 1 square root, which is going to be x squared over 25. Now when I split them apart, I get square root of x squared over square root of 25. Well, that's just going to be the absolute value of x over 5. Ooh, a lot of stuff here. I'm going to use the same technique. I'm going to combine them to get one big cube root of a fraction that I can simplify. 24 over 3, x cubed, y over y to the 4th. I'm going to cancel this. I'm going to cancel these, and I get 8. That means I've got the, cancel this, you get 3. That means you get the cube root of 8x cubed over y cubed. And when you take the cube root of all 3 of those factors, you get 2x over y. Simplified. The rule in general looks like this. And you have to make sure that a and b are both positive, but if they are, and if n is an integer, then it'll work. And if n is positive. Okay, 25. Well, I'm going to use a rule that comes up, a handy little rule that says you can take exponents and you can move them outside of the radicals. So it'll look like this. Exponent, I'm going to move it out of the radical. So then we get radical cube root of 27 all to the 10th power. Cube root of 27 is 3. 3 to the 10th power is the answer. Here, the square root of 3 to the 8th power. Well, I'm going to put it back in. Look at that. So then we have the square root of 3 to the 8th power. Square root of 3 to the 8th power, that's the same thing as the square root of 3 squared to the 4th power. I'm going to take the 4 and move it back out, so we get the square root of 3 squared, all to the 4th power. Square root of 3 squared, that's just going to be 3. 3 to the 4th power. Which I think I need to find. No, the answer is just 3 to the 4th. That's as simple as we need it. Okay, so we're going to try and combine these. And it looks like I can simplify this one. 20. Can I find a perfect square factor of 20? Let's see, 1 and 20, 2 and 10, 4 and 5. Aha! 4 is a perfect square factor. So this is going to be 8 times the square root of 4 times the square root of 5 minus 3 square roots of 5, 7 square roots of 5. So that means I can combine, let me simplify this first. 7 square roots of 5 plus 3 square roots of 5 minus 8 times, this is actually 2, 8 times 2 is 16, square roots of 5. So we've got 7 of these, plus 3 more of them, minus 16 of them, you get a negative 6 of them. Negative 6 square roots of 5. So 16 is not a perfect cubed, but I can find a perfect cube factor. That would be perfect cube 8. The perfect cube of 16 as a factor is also 8. 8 times 2 is 16, so I can split them up like this. In addition, y to the 4th is not a perfect cube, but I can find a perfect cube factor. Perfect cube factor of y to the 4th would be y to the 3rd. It really is a factor of y to the 4th. Let me show you why. 16, I can find factors, and the perfect cube is 8. For y to the 4th, I can say that y to the 4th has several factor pairs. 1 times y to the 4th, y times y cubed, y squared times y squared. The perfect cube factor here is y cubed. So I'm going to write this as the cube root of y. And then I also should bring down the 5 as well. Alright, let's simplify some things. The cube root of 8 will be 2. So this is going to be 5 times 2. And then we've got a cube root of 2. Cube root of y cubed is just going to be y. And then bring this down, the cube root of y. Alright, we can simplify some things. Let's multiply these together. We get 10 y cube root of, and I'm going to recombine the 2 and the y to get 2y. I'm going to bring this down. Maybe I should rewrite it a couple of times. Plus 7 cube root of 2y plus 7 cube root of 2y plus 7 cube root of 2y. We've got some like terms. The like terms are here. We've got 10y of these and 7 more of them, so I'm going to use grouping to factor them out and say that you got 10y plus 7 times the cube root of 2y, and this is the simplified answer you'll find in the back of the book. Here, last one. Let's multiply these two together. See what we get. Let's FOIL them. First term is going to be square root of 3 times 2 times the square root of 3. That's when you combine these together, the square root of 3 times square root of 3 is just 3, times 2 is 6. Outside term. We get square root of 3 times square root of 2, which is just going to be square root of 6. Inside term. We have another square root of 2 square root of 3. That would be negative 5 square roots of 2 times square roots of 3. Negative 5 times 2 is negative 10, and negative square root of 2 times square root of 3 is square root of 6. Last term would be here, 5 times square root of 2 times square root of 2, or negative 5 times square root of 2 times square root of 2. That's going to be 5 times 2. Or negative 5 times 2 is 10. Combining these terms, 6 plus negative 10 is negative 4. So the answer is going to be, oh, and then combining these terms, we get one of these plus negative 10 of them gives you negative 9 of them. Negative 9 square roots of 6. And that's the answer. So we're finished the video. I'd like you to get started on your assignment. I'd like you to start just the first problem on assignment 1G1. And I'll see you in class.